Hello and welcome to another one of D's ADD videos. Today we're going to look at some examples of the product rule. Again, basically the product rule states if you take the derivative of two variables, make sure they both have variables multiplied together, then you take the derivative of one times the other plus the derivative of the other times the first. If you're using u's and v's, it would be u prime v plus u prime u. In other words, basically you're going to take the derivative of one, leave the other one alone in both scenarios, and add them together. So here I have one expression here. That would be my u, that would be my v, or that would be my rectangle, that would be my triangle. However you want to look at it, it's fine with me. So I didn't leave myself much space, so the derivative of 4x squared would be an 8x times the other one with no change. And then plus the first one with no change times derivative of that, which would be bring that 3 down, rewrite your expression. This is the chain rule. You should already seen this video and practice this a little bit. And then we subtract 1 from this exponent of a 3 to get the 2, but then we have to multiply by the derivative of the inside. Alright? So what I recommend you do in this case is look for expressions that are common. Here I see that there's an x cubed plus 1 and x cubed plus 1. And the smallest power that they have common is a 2. So I can factor that out. And here I have an 8x, here I have a 4x squared with a 3x squared. So you can definitely put out an x and a 4. Okay, so let's do that. I'm going to write what I'm factoring out in green. So we're going to do a 4x and then an x cubed plus 1 squared. And then to figure out what's left behind, we do hat over factor. So if I were to take this whole expression here and divide it by what I'm factoring out here, go off to the side and do that if you're not familiar with this algebra. You should end up with what, a 2, and then subtract the exponents, x cubed plus 1, and then here we're going to have 4x, we're left with x times 3x squared is 3x, oop, there's another 3 right there, so that would be 9x cubed, right, because one of the x's went out, we're left with 1 here and then 2 there, and then x cubed plus 1 squared is gone. So that expression simplified rather nicely. And then you can distribute that through, you get a 2x cubed plus 2, and look, there's another x cubed term there. So what we can do is we can combine those and get an 11x cubed plus 2 times 4x. If you wanted to, you could distribute this 4x through, but I don't have much space. So I'm going to do that right there. So the answer here is, I'll write it up here somewhere, 4x x cubed plus 1 squared, but we factored out, right? And then times an 11x cubed plus 2. What I was talking about is you could distribute that through to get a 44x to the 4th plus 8x times the x cubed plus 1 squared. That could be your answer if you actually took the time to simplify it properly. It's beneficial to be able to do these because when you're doing max mins and stuff, you'll need to find critical numbers. The better your algebra, the better off you'll be. Alright, hopefully I left myself a little bit more space for this one. Again, bring down, rewrite, subtract 1, derivative of the inside, and then times the other with no change. And then plus the derivative of the other. 5x to the 4th plus 1 times the other with no change, which would be an x minus x squared cubed. That's a 3. Alright, so then algebraically I can pull out 2 of these, right? Because those are the same. And then I can pull out, there's 4 here and 3 of those there. So if I were to pull out that, numerically I don't think there's anything that I can pull out, so I would have an x minus x squared was the lowest power, and then x to the 5th plus x, oops, this was an x plus 3 cubed was the lowest one of those. So these 2 are gone, 3 of those are gone, so I have, I'm going to go ahead and distribute that 3 into these parentheses here. So last terms of the deal with 3 minus 6x. And then one of those guys left over because I only pulled out 3 of them, right? So x to the 5th plus x plus 3. Plus, all 3 of these are gone. They cancel when you divide them. 2 of those are gone, so we're left with the 4. I'm going to distribute that 4 through to get a 20x to the 4th plus 4 times one of those x minus x squareds. You could distribute all that through. That's getting too much into algebra here. We're trying to learn the product rule. So the last one we're going to do here, we have to do a little algebraic rewriting using the rule of changing radicals into fractional exponents. So this, if there's nothing there, it's a 2, and that's raised to a 1 if there's nothing there. So it would be x squared plus 1 to the 1/2 times 1 minus x cubed to the 7/3. So product rule, derivative of the first. Alright, let's continue on with the product rule. The product rule again states take the derivative of the first times the second plus the derivative of the second times the first with no change. So the derivative of the first is going to be this times the second with no change. I put that extra bracket there just to let you know that that's the one with no change, and then plus the derivative of the one that was in the bracket that didn't change, and then if I do the 7/3 minus 1 would be minus 3/3, so that would give me a 4/3 because you're going to subtract the numerators, and then times the 3x squared derivative of the inside, and then we're going to have the other one with no change, so that'd be an x squared plus 1 to the 1/2. Alright, so now a little algebra that we can do. I see that there is a 3 here and a 3 there that can go bye-bye. A 2 there and a 2 there that can go bye-bye. Let's say that those denominators didn't cancel. What you would do is you would find the common denominator, in this case a 1/6 or 6, right? And pull out that 1/6. And when you pull it out in front, it'll get rid of all the fractions if you do the Hanover factor. So here we're going to have a negative exponent that we don't like. This one's an improper one that we don't like, but the lowest common one for the positive exponents would be 1 minus x cubed to the 4/3, and then we're going to also factor out an x squared plus 1 to the negative 1/2 because we don't like that negative exponent. And then to figure out what's left, you take Hanover factor. So I had this whole expression right here. You follow that little circle right here. And I'm dividing by this in blue. Okay. So if I do that, you should be able to see that the x squared plus 1 to the negative 1/2 cancel. leaving me the x that's in front right here. And then if I divide these two, I would subtract 7/3 minus 4/3, which would give me 1 minus x cubed to the 3/3. Well, we know that 3/3 is just 1. Doing the same thing here, the 7 is going to get left behind. Then 1 minus x cubed to the 4/3 cancels. Ooh, there was an x common that I forgot that I could have taken out, right? So let's go ahead and do that so I don't make some of the people in the math world angry. So I know that there were some people going, what about that x? You could take out the x. So we're left with just an x here. And then if I do the 1 minus x, or the x squared plus 1 to the 1/2 divided by the x squared plus 1 to the negative 1/2, that's looking at two like bases, whatever they are, it doesn't matter. When you have that, you subtract, so it would be 1/2 minus a negative 1/2, which is 1/2 plus 1/2, which is 1. So we have a x squared plus 1 to the 1. So let's clean house a little bit. You don't need those parentheses. Distribute the 7x through. Combine your like terms. And also this negative exponent would need to go in the denominator. And the other expressions would come out for the fun and festivities as well. Okay, and that should be the answer you got. Why take the time to do this extra algebra here in a little while? You're probably going to be doing critical points and extrema. And if you have this set up the way I have it set up, you can just set the numerator individually equal to 0 and then solve that way. Sorry about that. I'm not sure what that was that fell. Then you can set the numerator individually equal to 0. Again, these are rough drafts, so I'm not going to worry about editing that out. I hope this has clarified any confusion that you might have over the product tool. Practice, practice, practice. Thank you and have a nice day.